Today's video will be looking at problem 704, binary search. As per usual, the 3 steps of solving any problem are 1. Understand it, 2. Visualize the solution, and 3. Implement said solution. So, given an array of integers nums which is sorted in ascending order and integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. You must write an algorithm with O log n runtime complexity. So example 1, we have this array, our target is 9. Let's look for it, it's right here. What's index? 4. So 0, 1, 2, 3, 4, output is 4. Example 2, we have this array, target is 2. We don't see that number at all, so the output is -1. Constraints, so the length of nums is between 1 and 104. Each value and target is between -104 and 104. All the integers are unique, and nums is sorted in ascending order. So, a linear runtime complexity solution would be where you just iterate through each number until you find the target. We can definitely do much better using binary search. So this is a standard algorithm that implements what's called the divide and conquer strategy. And the idea around to have divide and conquer is, rather than iterating one by one, we can just go to the middle number of the array, say, is this the target? Does this equal the target? If it does, then we're done. If it does not, we can just say, is it less than the target? If it is, then we just divide and conquer once again with the leftmost array. If it is larger than the target, then if the target is larger, then we divide and conquer on the right side of the array. To give an example of this kind of methodology, let's take example 1 again. So divide and conquer, so the number obviously, so if the array looked like this, we could just say it's the exact middle spot. So 3 on the left, 3 on the right, this is the exact middle. Our target is 9. So we say, no, it's actually, this number is too small. So then we just need to compare with, this new array, 9, 12, 15. We look at the middle number, 12. That is too large. And, at this point, there's only one number left, and that is 9. Now let's imagine, and so we can then just compare the remaining value. It's the exact number, so we return whatever this index is. Now looking at example 2, let's divide it, and we choose one of the two that are in the middle. So let's go with the leftmost, and say, does this equal the 2? It does not. It's too big. So then we compare this guy and then this guy with 2. Neither are, -1 is too small, 0 is too small, and we've already checked 3. So we can safely say that 2 does not exist in the array. So how do we actually implement this in code now? So we do need to, and the most complicated part is just figuring out how to say what the middle is, believe it or not. But just off the top, we can just say math floor nums.length divided by 2. The reason we did, so you could do math ceil. Math floor is will be a little bit more reliable in these kind of problems where you don't want to be on the upper bound of the array. So I always prefer to choose floor over ceil, but either should work. So let's say we have the middle, and so we do exactly what we said. So if nums middle equals target, then return middle. So that's if we went to the middle, we saw the value, it's the same, we're done. But now if nums middle is larger than target, so we actually our value is too large, then we need to come up with some sort of recursive function that then keeps diving into each of these, into the left side of the array, and if num's middle is too small, we need to keep going to the right. We also need some kind of search, some sort of recursive algorithm that, or function that will traverse until we find our solution. So let's go ahead and build this kind of function. So what kind of input does it need? So we still need the numbers, we need to know what target, and we need to set bounds for it, a left bound and a right bound. So let's look at our example one more time. So, the first number we checked, because we did floor, was 3, and we're looking for 9. So we looked at 3 and it's too small. So at this point we actually want to check, like no longer look at the entire array. We only want to look at the numbers between 5 and 12. So how do we do that? So we need to set like a left bound, or we just call it left and we call it right, and then we just need to figure out what the middle is in that range. So this is the definitely the trickiest part of a binary search algorithm, but it really just goes like this: middle equals, so we say math.floor again, and then we say right minus left, and this is divided by 2 plus left. The way I try to do this is I just like, it's hard to remember where to add and where to divide and where to subtract. So just like take any number. So let's look once more at our example. So our first number index was 2, and it was too small. So we want 1 over and then the final length of the array minus 1. So what's the length of the array? So 0, 1, 2, 3, 4, 5. So 5 minus 3 is 2. Divided by 2 is 1, plus 3 is 4. And that is right in the middle. So you can kind of just validate that your explanation for middle is correct with just throw in some basic numbers, and if it looks like it's correct, it probably is correct. If you say nums right plus left, you'll quickly realize that this is wrong if you just throw in some numbers. So you definitely just double check your middle value by throwing in numbers, and at this point we just do this exact same check once more of comparing the middle number with the target. So, and if it is that, then we do return middle. If it's too large, we just recursively run this same function. We have the nums, we have the target. We say we want middle plus 1. So we never want to touch the middle again because we already know it's wrong. So that's why we say middle plus 1. 1 second. So let's say this number is 5 and the target is 2. That means that we actually want to look towards the left. So we say left and then middle minus 1. And then in this case, so let's say the middle is 5 and the target is 9. That means we need to look on the right side of the array. Target middle plus 1. We never want to touch middle again. And then right. And we see a lot of repeat between this function and this function, so we can just delete all this now and just run our same function that we already wrote that's recursive, and we can plug in the values. So left will be 0, right will be nums length minus 1, and let's see how this guy does. So pass that case, let's see if it passes this case. We need to add here if left is greater than right. So this is a point where we've already tried out all the numbers using our divide and conquer strategy and none have worked. And at this point left, for whatever reason, is now greater than right, so we just return -1. And Let's try that out. And there you have it. So that's binary search. Thank you and catch you later.